Well, in this short lecture, we're going to calculate the derivatives of the natural log of x and the exponential function. I've subtitled it Getting Your Hands Dirty. This is sort of mathematical slang for, we're not going to be doing theoretical stuff. We're going to be doing work with actual particular functions. And so let's get to moving. So the derivative, we'll start off by taking the derivative of the natural log of x. And what we're going to be doing here is showing that the limit as x approaches a of the absolute value of 1 over a minus the fraction natural log of x minus natural log of a over x minus a is equal to 0. Okay. We're going to start out by assuming that x is between a over 2 and 3a over 2. This control is to keep x away from 0, where we won't have to worry about division by 0. So we're just concentrating in a short interval around the point a. Now, we can take the reciprocal of this inequality and see that 1 over x is between 2 over 3a and 2 over a. So we'll now use this control to analyze the value of our equation 1 up here. First, suppose that x is positive, or that x is greater than a. For values of x greater than a, I see that the natural log of x minus the natural log of a is equal to LAX, okay, the area under the curve. By using our formulas with regarding to area under the curve, I get that then that the natural log of x minus a being equal to L of AX is between 1 over x times x minus a and 1 over a times x minus a. By dividing all three pieces of this inequality by x minus a, which is positive, right, because x is bigger than a, I get that the natural log of x minus a over x minus a is between 1 over x and 1 over a. Given that, I can subtract 1 over a from all three pieces of my inequality and get that 1 over x minus 1 over a is less than natural log of x minus natural log of a over x minus a minus 1 over a is less than 0. I then, multiply this through by -1 to swap things around and get it in a more comfortable form for us. If I apply now, so now I have this 1 over a as a positive number, okay, or this 1 over a minus natural log of a over natural log of x minus natural log of a over x minus a. That's positive, and it's trapped less than this other positive number. So that gives us that the absolute value of this is less than the absolute value of this quantity, which I've simplified here, okay, by getting a common denominator. Now, that x in the denominator still bothers me, but I can use our restriction on x. Okay, let's back on the previous page, this right here, that 1 over x is less than 2 over a, to get that 1 over ax is less than 2 over a squared. I can then substitute that into our inequality above and get that 1 over a minus the natural log of x minus natural log of a over x minus a in absolute values is less than 2 over a squared x minus a. And so this is under the assumption that x is bigger than a. Okay, now let's suppose that a is bigger than x. Then my natural log of x minus the natural log of a is equal to the negative of the natural log of xa. As before, I can get my inequality on on L of ax between 1 over x minus a and 1 over x times a minus x. And then I can argue as before that my difference quotient is between 1 over a and 1 over x. And again, just copying what I did on the previous page, I can get this to be that my difference quotient in absolute value is trapped less than 2 over a squared times x minus a. Now, I can then, since this same inequality, right, is true whether a is bigger than x or x is bigger than a, I can do my epsilonics and show that in fact that the limit, as I limit x approaching a, that this is equal to 0, and so my derivative is as it should be. That by the squeeze principle, I can say that this limit is equal to 0, and therefore my derivative of the natural log of x at x equal a is equal to 1 over a. So, going back to what's the derivative of exponential? Well, here I'm just apply the theorem on the derivative of inverse function. The derivative of the exponential at a is the exponential evaluated at a. Bang, we're done.